5H, Instantaneous Velocity. Instantaneous velocity is an object's velocity at an exact moment in time. Remember, velocity is the rate change in position, or how quickly an object is moving relative to a reference point, or the rate of displacement. This graph shows an object with uniform motion. It displaces an equal amount for each set interval of time. If one were to ask for the velocity of the object, you would simply calculate the slope of the line. Now, since the line is straight, then average velocity is equal to velocity. It's a constant. Using the slope of the line, then slope equals 5 meters per second forwards. From our math knowledge, we know that the slope of a straight line is a constant across the length of the line. So the velocity of the object at any time is the same. The slope at 5 seconds is also 5 meters per second forward. The slope at 10 seconds is also 5 meters per second forwards. In fact, it is 5 meters per second forward at every moment on the graph. One could say that the velocity at any instant in time is 5 meters per second forward. For this straight line graph, the velocity is 5 meters per second. The average velocity is 5 meters per second forwards. And the instantaneous velocity for all moments of this data is also 5 meters per second forwards. In fact, when one is asking for velocity, they are asking for instantaneous velocity. This graph shows an object that is not traveling at uniform motion. It does not displace an equal amount for each set time interval. In fact, this object displaces a greater and greater amount for each second of time. This object is speeding up as it moves in the forward direction. If you were to ask to calculate the velocity of this object, with our knowledge from our previous lessons, we would only be able to calculate average velocity from, say, time A to B. For this example, we'll calculate average velocity from time 0 to time 5. The formula would be change in position over change in time from time 0 to time 5. Now, essentially what we'll be doing is calculating the slope of this line, joining the data point at 0 seconds to the data point at 5 seconds. Plugging in the values, V average from time 0 to time 5 is 6.2 minus 0 meters forwards divided by 5 minus 0 seconds. That calculates to 6.2 meters forwards over 5 seconds, which makes 1.24 meters per second forwards. We could calculate this average velocity for an infinitely large set of values. For a second example, what is the average velocity from time 1 to time 3 seconds? Again, our equation is change in position over change in time from time 1 to time 3 seconds, which equals to 2.2 minus 0.2 meters forwards divided by 3 minus 1 seconds. This makes 2.0 meters forwards divided by 2 seconds. Our final answer is 1 meters per second forward. Now, the reason that we could only calculate average velocity and not velocity of this object is because the object's velocity keeps changing. So in order to calculate velocity of an object that is accelerating, we need to ask at what time do you want the velocity? We call this the instantaneous velocity. To calculate instantaneous velocity, we will estimate the slope of the point as though the point was an infinitely short line. To do so, we need to remember a few math terms. The first is secant line. A secant line is a line that passes through a curve and intersects the curve twice. The second term is tangent. A tangent line is a line that only touches a curve and does not intersect it. As you can see, a secant line is one that could be used to calculate the average velocity of an accelerating object between 2 points of time. As the 2 points move closer together on the curve, the secant line becomes shorter and shorter. Eventually, as the 2 points come closer and closer together, the secant line turns into a tangent line, and the slope of it will estimate the velocity of the object at that point in time. Here you can see an animation of the secant line become shorter and shorter into a tangent line. Let's use our first graph's data and see if we can calculate instantaneous velocity. From time 0 to 5 seconds, we calculated the slope to be 1.24 meters per second forwards. Now let's calculate the velocity at time 2 seconds. To do so, we'll draw a tangent line at 2 seconds, a line that touches the curve at 2 seconds but does not intersect the curve. Now we'll calculate the slope of the black tangent line and we'll have the instantaneous velocity at 2 seconds. To do so, we'll choose any 2 points on the black line to calculate the slope. We'll choose the coordinate points at time 1 second and at time 5 seconds. The velocity at time 2 seconds equals 4 minus 0 meters forwards divided by 5 minus 1 seconds. That equals to 4 meters forwards divided by 4 seconds. The instantaneous velocity at time equals to 2 seconds is 1 meters per second forward. It's important to remember, when calculating instantaneous velocity, we use 2 points on the tangent line that we drew and not 2 points on the original curve.